So we're back, and I just want to go over the drivers that I'm going to be using in these two new coil builds. For the half bridge assembly, I'm going to be using the standard universal driver, 1000 amps, with the low power phase indicator, or inductor, I'm sorry, tuning inductor. And the high power inductor in this freewheeling universal driver, that's 2000 amps. So for the big coil, it's going to be running two CM300 24H DY IGBTs in a full bridge setup. For the cap bank on that one, for the big freewheeling 680 volt DR, it's going to be using Dawn caps, which are rated for each at 47 nanofarads, 3000 volts AC, 6000 volts DC at 80 amps RMS. For peak pulse amperage, it's 1645 amps, 1645 amps. So 5 in series, 2 in parallel, which would bring the total output of the MMC for the big 680 volt DR to 12,000 volts AC, 3,290 amps peak rated, and 160 amps RMS, and that would be 24,000 volts DC rated. So that's 5 in series, 2 in parallel. For the half bridge coil, I have the old microbrute setup, and I'm debating raising this secondary up from, it's 10.5 inch with 10 inch windings, 4.5 inch diameter secondary with 6 turns. I'm going to be running 8 of these Coil 940Cs, if it focus. Let me see. These 940Cs, 15 microfarads each, and it's going to be 75 nanofarads, same as the microbrute, but just a stronger system. I was running that microbrute at about 800 amps on those SOT227 transistors, and they held up pretty well, but whenever you'd have a strike to the rail or a strike to the ground, that was the problem. It would cause the gates to instantly latch up, probably just backfeed. I'm not really too sure. It was a good system, but I just need something more robust. So from here, I raised these from about 4 to 7 inches, and I'm actually doing the base right now. So once those Cornell caps get here, the other 6 that I've ordered, I'll put those in a configuration and get that all wired up. Waiting for a MIDI interrupter from Eastern Voltage and a reference 2.0 bus bar for the big freewheeling coil. The toroid up here is 3.5 by 12. Resonates at 191 kilohertz, I think, as I said before. The big coil. The big coil, I have these specs right here. So it's going to be running a 6-inch secondary, basically starting at 1 3/16, ending at 32 inches for the winding total. So 1,525 turns, 24 gauge. The primary is going to be 3/8, which I actually had that sitting on top of that Victrola cabinet. It was already turned out, but standard tuning resonant is 5.79 turns. In between turn spacing is 1/4 inch. The toroid is 7 by 30, and that is from Eastern Voltage Research. That's a spun toroid. Total nanofarads for that system is going to be 188 nanofarads, and it's going to resonate at 91.5 kilohertz. And the proximity is 1.5 inches. So here are the specs for that. For detuning, I actually made the primary out to where, you know, you can be 15% detuned. But for max detuning, I think I had it labeled wrong, 15% detuning on the actual max page. it was 8 turns, where the max would be about 27% detuned. So the primary would be detuned down to 66 kilohertz from the secondary at 91. Freewheeling, you want to basically detune more and more, especially at high voltages, because your primary, if your bus is at 680 volts, then your primary is going to be at 1,360 volts, 4 times the power, as Archangel Tesla Coil was explaining to me, which makes sense. Energy transfer time and the coupling coefficient, I don't want racing arcs, especially if I'm going to be running up to 1,000 amps. So I want to keep the proximity at about 1.5 inches, and water cool it as well. I think the transistors are the only things that I really have to worry about, although I will end up cooling the capacitors too, just in case. Even though they're Dawn caps, and I've heard they're very, very resilient, I will probably end up cooling those as well. But everything is coming together so far, and using 1,000 to 1 current transformers and feedback transformers with everything. And the heat sink for this is right here. I actually drilled and tapped the top for the GDT, for the 5001 GDT, which they're sitting right there. They're ready to go. Have your snubber on the half bridge system, and your snubbers right there. The IGBTs are in there, along with the current transformers and a bunch of other miscellaneous stuff. So, to hold it on there, the secondary into place, basically I used an expanding rubber plug nut on the bottom that goes through the wood base and tightened from the top a nylon 3/8 bolt, and it'll basically expand out here inside of the secondary. I love these pipe plugs for attaching toroids and secondaries. They work very well, but you have to be level with them. So that's about it for now. Other than that, just stay tuned, you guys. Hopefully in the next month or two we'll have a running coil. Probably by next week I should have the half bridge coil up and running, but I may have to experiment with it. I might actually raise that secondary up to 12 inches, just because I don't know if I'm going to have any toroidal inductance to the primary from here. The only thing is to really just check and see, but the breakout point will definitely have to be longer than what it is right there. So, thanks for watching, you guys, and y'all have a great weekend, and happy Mother's Day to all the mothers out there. And God bless you guys. Thanks for watching.